Hello, today we're going to talk about 5.4, the first part of dividing polynomials. There are two ways to divide polynomials. The first way is long division, the second is synthetic. So, long division first. Long division goes off of our old skills, so what we are used to. So, let's first remember how we divide 571 by 2. So we divide it by 2, so 2 goes on the outside. Then we have what looks like a square root, but it's your division sign, 571. Okay, we go, how many times can 2 go into 5? Well, you put 2 times. Okay, so 2 times 2 is 4. 5 minus 4 is 1. And then you bring down the next term. 2 can go into that 8 times. So 8 times 2 is 16. So you multiply there. Then you subtract. You bring down your terms. Or I'm sorry, your numbers. 2 can go into 11 5 times. 2 times 5. We get 10. We subtract. All right. Now we don't have any other numbers, so we can't bring anything else down, and 2 can't go into 1, so we call that the remainder. Okay, we can also tell because we've stopped, right? There's nothing left here. So we have 285 with a remainder of 1. All right, that was kind of the elementary school way to write it. Okay, then we started getting into fractions, and then you wrote 285 and 1/2. Right? Because you were dividing by 2. So these were your two ways of writing your answer. So now let's do it with polynomials. All right, jazz it up some. So how do we do this? Well, we're dividing by the 2x plus 1, so that's what goes out front. Then we do our division sign, and we set it up like this. I make sure to separate it by the terms. Okay, so I try to give myself some space, and then I'm going to set it up with columns and try to line everything up. So that way, if I do that, it kind of gives me some signals on when I'm done. Okay, so we can go 2x can go into 6x squared. Okay, so you can think of it as division, or you can think of, okay, what times 2x will get me this? All right, well, 2x times 3x is going to give me 6x squared, right? If I multiply, so if we multiply this, we're going to get 6x squared. Okay, which is the same term as what we had up here. Okay, that was what our goal was. Well, if we multiply the 2x, we also have to multiply the other term, so the 1. So 3x times 1 gets us plus 3x. I know, it seems really foreign, okay? Just trust me, okay? Take a minute. 2x times what gets me this term underneath? So 2x times 3x. Well, then I also have to multiply it by the 1. Okay? Just like we did before. We did 2 times 2 and got 4. Then the next step was subtraction. So we change our signs. Okay? So this becomes a negative and this becomes a negative. We're subtracting them. We subtract. This should go away. We get 4x. And I'm going to just bring down my other term. We do it again. 2x times what is going to get me 4x? Well, 2x times 2 is going to get me 4x, right? Again, we multiply it. So we get 4x plus 2. You got to multiply it by both terms. Then we subtract, so we change the signs. And notice this is nice because the 4x's cancel and the 2's. So we're left with nothing. So this would just be 0, right? Where we don't have a remainder here. So my answer is just 3x plus 2. Okay, what was up top? I know, we're going to keep doing it. So we get x plus 5 out front. Then I put 4x squared plus 23x minus 16. So x can go into 4x squared 4x times, because 4x times x is 4x squared. 4x times 5 is 20x. Then we subtract. These cancel. So we get 3x, bring down the 16. X times positive 3 gets me 3x. 3 times 5 is 15. Change your signs. We get negative 16 minus 15 is negative 31. I can't make x look like negative 31, right? I don't want to multiply by some gross fraction. So this represents my remainder. When you get down to the last column, that's your remainder. So here we have 4x plus 3, remainder of negative 31. Some textbooks write it this way, all right? But usually in upper level math, you write it as a complete expression, and R is not an expression. So the more formal or standard way that you will see on standardized tests, all right, will be 4x plus 3. And since it's a remainder of a negative number, we put minus 31 over what we were dividing by. So x plus 5. Right? Think about what we did here. We had the remainder of 1, and we put it over what we divided by. So over that 1/2. Okay? So the remainder of 1 over what we divided by. Remainder over what we divided by. So this is your more official way. Okay? Yes, I'll take this, okay? All right, I just want you to get familiar with it. All right, let's do another one. Okay? So watch how I set this one up. We do 2x squared minus x minus 3. So that has 3 terms. So make sure you multiply it 3 times. All right, now here I like to set up my columns. So you got to represent all your degrees. We have 4x to the 4th minus 2x cubed. There's no x squared, so 0x squared minus 3x minus 9. It's so I can have all my columns represented, so that way I know when I get down to here, that's my remainder. Okay, that's how I can tell I'm done. So let's multiply. 2x squared times what? Well, times another 2x squared. 2 times 2 is 4. X squared times x squared, right? We want those to match. Then we do 2x squared times negative x, so negative 2x cubed. 2x squared times negative 3 is negative 6x squared. Got to multiply by all 3 things. Then change your signs, because we've got to subtract. So here, well, this is great because this cancels and this cancels. So now we get 6x squared minus 3x minus 9. So since this canceled, we're not going to get an x term. There's not going to be anything here. So 2x squared times what to get 6x squared is positive 3. Notice I skipped. I went from x squared to no x. Okay, so 3 times 2x squared is 6x squared. 3 times negative x. 3 times negative 3. This is great because this cancels, and wait, this is supposed to cancel. Did I not write 9? I was so excited. 3 times negative 3 is, let's see, did I do this right? I got excited. 3 times negative 3 is negative 9. Yes. Then the sign changes to a positive, and it does become 0. So since these canceled, that means we don't have a term here or here. So our answer is just 2x squared plus 3. Does this make sense? Hopefully. Okay. All right, let's keep working. All right, so another way of division is, well, I can ask you, is it a factor? So let's think about it with just numbers. You know, how do you know if 2 is a factor of 10? Well, we go, does it divide? Well, yeah, 10 divided by 2 is 5, so that divides nice. So yeah, 2 is a factor of 10. But is 2 a factor of 31? Well, no, because it doesn't divide evenly, right? What does that mean, evenly? Well, there's no remainder. There's no leftover. So we can ask the same thing about polynomials, right? If we're trying to factor something, we can ask if this is a factor of something else, because I shouldn't get a remainder. All right, so we know 2 is a factor of 50 because it has no remainder. All right, so let's do, is x squared plus 1 a factor of this polynomial? So write it out. X squared plus 1, 3x to the 4th minus 4x cubed plus 12x squared plus 0x plus 5. All right, just because I like to do columns. You don't have to. All right, it's just a thing I do. All right, so x squared times 3x squared will get me 3x to the 4th. X squared times 1 is 1x squared, so notice where I put that. Change our signs. So we get negative 4x cubed plus 11x squared. Notice I set it up this way so I don't accidentally combine the wrong ones. I see a lot of kids put this underneath the x cubed and subtract the wrong things. Okay, so just be careful there. So here we have, well, plus 5. Okay, if you want to write the 0x, that's fine. So x squared times negative 4x is going to get me negative 4x cubed, and then minus 4x. Change your signs. We get 11x squared plus 4x plus 5. Then we can multiply by positive 11. So 11x squared plus 11. Change our signs. We get 4x minus 6. Now, I can't make x squared look like 4x. So I know it would seem that I would stop here, right? I always said on the last column, but actually we have to stop here at the x because I can't make x squared look like an x. So this is actually my stopping point. You stop 1 degree less than what you're dividing by. So my answer here is 3x squared minus 4x plus 11, remainder of 4x minus 6, or the more proper way, 3x squared minus 4x plus 11, plus my fraction, 4x minus 6 over x squared plus 1. Okay. Oh, I'm sorry. This is not the question. This was your how we divide it, but the question was, is it a factor? So is it a factor? No. Okay. Why? Because it has a remainder, of 4x minus 6. So it's important to explain why. Okay, don't just tell me no, right? Because then you have a 50-50 chance, right? That's what kids think. They're like, oh, I'll just guess yes or no. Okay, no. Tell me no because it has what remainder? That's your reason why. I want to make sure you know why. All right, so why don't you guys practice this one? Okay, so given these polynomials, are they factors of this one? So check these binomials, all right, with this polynomial of 4 terms. Really, there's no fancy name for that. All right, so check it with division. Okay, so hopefully this is what you got when you divided. All right, that's the first step, divide. All right, now how do we know if it's a factor? Remember, 2 was a factor of 10 because it went into it evenly, so no remainder. So 6 is a factor. X plus 4 is a factor of this polynomial. All right, also number 8, no remainder, so that is also a factor. Number 7 is not, all right, because remainder is negative 72. Okay, so right, because your remainder is negative 72. All right, that's why number 7 is x plus 6 is not a factor. Okay? All right, well, that's it for factors and with long division. All right, tune in for the next video for synthetic.